Today on NerdOut, Midgard. Welcome back to NerdOut, the show where we take a look at Cardano and we break it down, but we don't dumb it down. Today we're talking about the Layer 2 solution Midgard. And for this episode, we're going to do something a little different. I had a sit-down interview with George from the Midgard team. It's a little bit of a more long format video, so strap in. It's going to be a nice long ride. We're going to dive very deep into what Midgard is all about. So sit back, relax, and enjoy the content.
Yeah, let's do it that way. Yeah, so we'll just use your Google recording. All right, cool. So Midgard.
Yeah, why don't you start by introducing yourself in case we share this video later, and how you got started in Midgard.
Yeah, so my name is George Slarowski. I'm a Cardano smart contract developer, protocol architect, project manager, all sorts of things. Developer. So I got involved with Midgard when I was invited into the project early, right before it was proposed in Project Catalyst Fund 12. So I came in, I helped a little bit with the proposal, and then later on I helped conceptually when the idea was coming together. And so far, mostly I've been helping with the specification, so kind of putting stuff on paper. That was mostly Phil and Jonathan's heads at the time, and I mean I contributed some ideas as well. And managing the team, assigning tasks, reviewing stuff, making sure that things kind of move forward. So that's been my contribution so far. And then lately I've been going into the code base more myself. I've had that opportunity now. It was kind of hard to do that when I was in spec mode before, because writing documents and writing code at the same time requires context switching all the time. So you kind of do one or the other. Yes. Now that the spec has critical mass, I'm able to go into the code a little bit more. So that's nice.
Awesome. So let's start. Assume I know. I mean, I've read the Midgard white paper, but assume I know nothing. Like, what is a 2 to or a 1 paragraph summary of what is Midgard?
Yeah, so Midgard is Cardano's first optimistic rollup protocol. Now, what does that mean? That means that we are able to offload transaction processing that would normally occur on Cardano's main network, right? And let's recall Cardano's main network, when you submit a transaction, you submit it to a local node, and then that gets distributed to all the other nodes on Cardano's network via gossip, so peer-to-peer, and then that peer-to-peer, and so on, right? And every single node along the way has to evaluate your transaction before deciding to propagate it further. So propagation of this is fairly slow, and also eventually this transaction has to reach a slot leader who's going to produce the next block, and there's limited space in that block because, again, the block has to be fairly compact so that it can be transmitted across the network and with reasonable timing, reach a majority of the network, or 95% of the network.
Seconds. Yeah, it's got to reach the next node within 5 seconds, otherwise things start falling apart. So
exactly. And so you as a stake pool operator know all about this in practice, right? What this means. So so you can appreciate that because of these latency constraints, it effectively throttles the amount of throughput that we can push through the system, the amount of transactions that we can fit into a block. So the number one goal of Midgard is to relieve that constraint. So we want to potentially have as many transactions per block as we can possibly process off chain, right? And off chain, this stuff can be done a lot faster, because if we piggyback on the L1 to run our consensus for off-chain based transactions, essentially making sure that they're all valid and stuff, right? Then in terms of the amount of transaction that we can process off chain, it's just a matter of how many can you physically crunch through on a single node, essentially, right?
Mm-hmm.
And then we just rotate who gets to be the node that processes transaction at any given moment, type of thing.
Yeah.
So that's the big idea.
Yeah, let's talk a little bit about that. You mentioned rotating nodes, who gets to process the Midgard block. Now, a Midgard block is just a transaction that's going to go on the L1, right? So it's like a roll up of everything that occurred off chain.
Yeah, exactly.
So how does your consensus for Midgard differ from Cardano's Ouroboros consensus?
Yeah, so we don't use Ouroboros for Midgard. That's actually a key part, right? So we use the same ledger, more or less. We're modifying it a little bit for reasons to be explained, right? But mostly we try to be as isomorphic as possible, right? And the main difference is our consensus. We're not using Ouroboros, so we're not doing this, proof of stake stuff on a separate network from Cardano. Instead, we are using smart contracts on Cardano itself as our consensus protocol, right? It's a smart contract-based consensus protocol, which means that whoever is producing the blocks off-chain, right, has to post a fixed size summary of that block, right? Essentially, like a fixed size block header gets posted on chain into a queue, right? And then the optimistic part comes in that once he posts the block header into the queue, to the end of the queue, it has to sit there for a maturity period, right? So notionally, let's call it 3 days or something, right? 5 days. We're going to pin down the specific period length that makes sense a little bit later on when we have benchmarks and things like that going on. But the key point is that we need this maturity period to provide an opportunity for anybody out there to be able to take a look at the contents of this block, right? Verify that it's valid, right? And if it is invalid, to be able to construct a proof that pinpoints the specific location in the block that it is invalid, right? Submit that on chain, get that verified on chain, and then disqualify this block, removing it from the queue, and slash the bond of the operator that posted that block. Right?
Okay, so let's talk a little bit about that. How does, you mentioned posting a bond, how does one become a validator, and what are the requirements to run a validator?
Yeah. So in terms of the on-chain consensus, like the smart contract-based consensus protocol, we have a data structure called the operator directory, right? It's split up into 3 parts. We have a register. We have a registered operator queue. So these are the ones who have registered but have not yet become active operators. We have the active operators who are in rotation to produce blocks, right? And then we have the retired operators. So at any time, any active operator can declare themselves to be retired, take themselves out of rotation, but they have to stay in the operator directory until their latest block that they've committed has matured, right? Because they still need to be on the hook in case they had, they committed fraud, right?
Right. And if they stop, then they get slashed. Is that correct?
What's that?
Do they get slashed if they leave before their last block is committed?
No, that's totally fine. The point is they aren't able to remove themselves from the operator directory.
Okay.
Until their last block has been committed. That's why we have this retired operator queue, right?
Okay. Yeah, but I'm saying, like, what if an operator is in the active queue and they don't do what they're supposed to do? They don't validate their block when it comes.
Oh, that's separate. We skip to the next operator.
Okay.
Right? We give this current operator, some time of, like, maybe off-chain is not very active right now or something, right? But then we skip to the next operator, right? So right now, in terms of the way it's written in the spec, we're not actually slashing operators for inactivity. We're just skipping to the next one. But I could see, if it gets really bad or something, maybe 3 strikes are out type of thing. Not sure. There might be some slashing involved for operator inactivity. We'll see if that's needed. It's something that we'll really need to test out more with simulations and testnet and stuff to see kind of what incentives work best for that. But yeah, so anyway, so we have registered operators. We queue them up so as to not disrupt the normal, like, rotation in the active operators. We want that to be more predictable, right? So we want them to have, like, we want to be controlled about when we inject the new registered operators into the active operator rotation, right? And then for retired operators, they're able to leave at any time, going to the they're able to leave the active operator list at any time, going into the retired operator list, right? And that takes them out of rotation immediately, and then they have to sit around and wait for their latest committed block to mature and emerge into the into the confirmed state of Midgard, and that's when they can recover their bond and remove themselves from the operator directory.
Okay.
So that's how that works. And anybody, well, eventually, I'm not sure if we'll at mainnet launch, we will immediately open up the operator directory to anybody to operate, right?
Mm-hmm.
That's a TBD thing, but the idea is that it's just a smart contract, right? So eventually, like if you remove all the permissioning and stuff, right, which maybe there's a guardrail initially, like I'm not sure that's more of a Phil and Anastasia Labs decision about pay grade, but in terms of the smart contracts themselves, theoretically, the operator directory should just be open to anybody to post a bond, append themselves to the registered operator queue, and then when the time comes, they will be inserted into rotation.
Yeah,
So,
I assume there is some type of max limit just based on datum size on chain that can hold this directory, correct? Or is that off chain? And
no, there is no, because the operator directory as a data structure is implemented as a linked list, as an on-chain link.
Okay, so you can just continue adding.
UTXO in this data structure that points to the next operator in the list, right?
Okay.
And it's very easy to insert and remove whenever you want in this linked list data structure, which by the way, we reuse all over our smart contracts, right? Whenever you want to insert a node into the linked list, all you have to do is modify its predecessor's node to point at it, and then modify, and then the node you're inserting has to point at whatever your predecessor used to point to, right? So typical kind of linked list operation. And then the reverse of that when you remove a node from a linked list, right? If you remove the node, you have to rewire it to, to link
and
up.
then the smart contract checks to make sure all those rewiring of links are valid. That's really, really slick.
Yeah. And we use this all over the place because we have, so this linked list data structure very conveniently can work as an on-chain set, right? Which allows you to define on-chain the universe of things that belong in in some collection, right? And we can also use it as more of like a queue mechanism where you can add, append things on one side, remove things on the other side, remove things from the middle if you allow it, right? Those kinds of things. So Midgard's on-chain contracts, a lot of them essentially are queues or sets. They use queue or set data structures. And so that's why we actually ended up implementing linked list as a library of handlers, which can then be invoked from the relevant minting policies of the various lists and sets and queues.
So have you made any decisions around bond sizes for operators or incentives for operators?
Yeah, so I mean, a lot of these things are TBD because we need to see the performance of the system, right? So we actually we talked about this a little bit in the introduction, right? So the security and finality properties are mostly guaranteed by the size of the bond, by the reward for preventing an invalid block from being merged, right? So we want the bond size to be like the larger the block, the less incentive to commit fraud. The larger the reward, the higher the probability that fraud will be detected and submitted on chain, right? So that deters fraud as well. The waiting period between the maturity period, essentially, for committed blocks to be merged into the confirmed Midgard state, that gives more opportunity for a block to be detected and therefore deters fraud. And the data availability layer, right, has to be actually like available, right, for people to be able to access it and detect the fraud, right? So those things together form the kind of the guarantee for the security of Midgard's protocol. And so a key aspect of this is if the waiting period is sufficient and the reward is sufficient, right, and the procedure to to verify a block, right, to correct it so a block is cheap enough, right, and if fraud is detected. The fraud-proof construction procedure is also simple, cheap, and fast enough, right, that anybody can do it kind of on a whim, right? Then those things together, they reduce the need to have as big of a bond requirement, right? Because the easier you make it for people to be vigilant, right, the more of them will be watching, and therefore, like, even if the operator doesn't have as large of a bond at stake, he knows that fraud is not going to pass through. So his expected return on trying to commit fraud becomes very small anyway. And the thing is, if fraud is detected, there is no way that the operator can possibly profit, because first of all, his block takes no effect because it's just removed before it ever gets merged to the confirmed state. And second of all, he loses the bond. So it's a definitely negative cost, like definitely negative profit. If the fraud is detected, the only way the operator can possibly profit is if the block does not get detected for that entire maturity period and somehow gets merged into the confirmed state. So we have several knobs to calibrate, right, to ensure that a committed block never makes it into the confirmed state if it's fraudulent.
Okay, but as far as like incentives for the normal state where there is no fraud, there's no real incentive for that, or
let's talk about that. Well, first of all, what's the incentive for operators to continue producing blocks? Well, the idea is they'll be collecting fees from L2 for the transactions that they process. So we haven't specified the specific fee structure yet, right? Because
I assume much smaller than the L1, though, right?
Yeah, because we have this scale benefit, volume, right?
Ideally.
Yeah, exactly. So right now the spec does not say anything about fees, because I find it easier usually to design a protocol without thinking about fees first, and to implement a prototype of it that doesn't do this, and then to adapt it around a fee structure, right? As opposed, because when things are still in flux, it's very hard when you also have to think about like this fee structure changing along with it, right? So once things kind of stabilize, that's when we'll inject the fee structure. But in principle, the operators can collect fees for the LP transactions that they process, for the deposits that they process, and for the withdrawals that they pay out, right? Everywhere along the way, fees can be collected, right? Now, of course, fees can potentially be collected separate from when they actually get paid out to operators, right? That doesn't necessarily have to happen, every time, right? But you get the point, right? And so that forms the incentive for operators to operate at all, right? Their cost is the cost of them obviously running their hardware to process these transactions and everything, plus the on-chain cost of committing blocks, merging blocks, and paying out withdrawals, also absorbing deposits, all that kind of stuff, right? Especially all these L1 gears that through which the consensus protocol operates, right, have to be earned mostly by the operators, right? So that's where the cost comes from, and so our fees have to be sufficient to compensate them for those costs, plus earn a little bit of a profit so that they are incentivized to continue being an operator, and also to compensate them for the opportunity cost of their bond, because you have to keep that in mind as well, right? If your bond is locked up in Midgard, you can't do something else with this money, right? But due to we expect if the volume of transactions going through Midgard, as that increases, the incremental fee per transaction, right, should decrease, because you are able to pay operators a fairly decent profit without necessarily while spreading that out across more transactions on L2. So theoretically, Midgard transactions become very competitive against L1 transactions in terms of transaction fees once a certain scale is reached.
Yeah, so let's talk a little bit about the main point of Midgard that you brought up at the beginning, which is the speed. How do you gain that speed, and does Midgard still deal with some of the problems we see on the L1, like UTXO contention and other things, or does it eliminate some of that stuff?
Well, UTXO contention exists in any UTXO-based ledger. Midgard uses a UTXO-based ledger, therefore it has UTXO contention, right? So that still remains. What was the other thing you mentioned?
What makes it fast? Like,
yeah, what makes it fast? Well, what makes it fast is that we are able to the operator, who's the current operator, right, is able to receive transactions and just put as many transactions as it wants into a block and then commit it to the on-chain. It doesn't have to wait for a block to be to be confirmed before it can create the next block to put transactions into it, right? So it's able to accept transactions at the speed of receiving the transaction, verifying that it works against its ledger state, and then just adding it to a block. And the blocks themselves are just continuously being committed on chain, but the current operator has exclusivity in terms of committing to the committing to the state queue on chain, right? And so you can just continue producing blocks as needed, and the speed at which he's able to accept transactions doesn't suffer at this time, right?
So yeah, so when somebody wants to commit a new L2 transaction to Midgard, do they have to interact specifically with the next block producer, or can they submit to any validator, and then is there some type of gossip protocol, or how does that work? Where does my transaction go if I do something on Midgard?
Yeah, this is we're working through several possibilities here, right? Yeah, at a very basic level, as you identified, you could just send it to the next operator, or in fact, you could just broadcast it to all the validators, right? Or the next N validators, and then one of them is going to pick it up. It doesn't really matter which one, right? And that's something that's probably what Solana does, for example, right? I think you just blast it, to all or the next few operators, and then one of them is going to pick it up and post it on chain or something. We're able to run at that speed, right? And so what happens is, so you blast your transaction to the next the next K validators, right? One of them it turns out is the current operator, so he's the one that puts it into his block, right? And then once he assembles this block, he submits it on chain. He submits the corresponding block header on chain, right? And then state queue. And then once that transaction is confirmed, right, that block is in the state queue, for a fact that this block will get merged to the Midgard confirmed state as long as all of its predecessors are valid and it itself is valid, right? So even though the actual merging into the confirmed state is delayed by the maturity period, right? If you've been following along what's been going on off chain, right? You've been following along to all the blocks that have been posted so far, and you verify that all of them have been correct so far, and you see that this new block that contains your transaction is also correct, then you know for sure that at that moment, it is as good as confirmed, right? From your perspective. It's just not settlable. So any withdrawals that it contains must wait until they get into the confirmed Midgard state, right? Before they can be paid out. But other than that, the actual L2 ledger state can be considered to be confirmed as soon as that block is in the state queue, right? And that's a key thing, right? And the relative to L1, right? You're still getting the delay of, a transaction has to be confirmed on L1 somewhere, right? But the difference is that whereas traditionally in Cardano, when you submit an L1 transaction, your transaction has to be confirmed, but it's competing for block space with all the other transactions on L1. Whereas in Midgard, it happens all in lockstep. As soon as this one transaction that commits this block header to the state queue is confirmed, right? All of the transactions mentioned by this block header are all confirmed in lockstep, right? So that's where the throughput benefit comes in, right? We're confirming multiple transactions at a time with a single L1 Cardano transaction.
So you mentioned following along off chain. How does one do that? How will we bring wallets into this ecosystem? Because I assume wallets will have to know about Midgard and have some type of wallet backend to know what's happening on Midgard. How is that all being thought about?
Yeah, so this is a critical piece of Midgard security because, as I mentioned, you need visibility in order to be able to detect fraud, right?
Right.
Because if you don't have visibility, then you will never be able to see that, that some operator's trying to, slip something under the radar, right? So the data availability layer is key for the consensus of Midgard, right? And so that operates at the level of, okay, somewhere the block contents have to be made available to anybody who wants to look at them, right? And so there are several options for the data availability layer that we're exploring. The long-term solution, I think, is going to be Leo's blobs. So the idea with Leo's blobs, and obviously this is TBD in terms of Leo's own roadmap, but the idea is that you should be able to post a binary blob for a period of, say, 30 days that, essentially SPOs or nodes on Cardano are going to store for those 30 days and get compensated for that, right? And that gives you the availability for those 30 days, which is more than enough for our, 3, 5, 7 day waiting, maturity period to have that data be available with guarantees, from the L1 Cardano blockchain. That's probably the strongest data availability guarantee that we can make because Cardano's data replication is just, huge, right?
Have you guys thought about some of the other protocols on Cardano for that, like Iagon, because that may be available well before Leos comes around?
Yeah. So I just said that this is the long-term solution that I think would probably be the ideal for Midgard, because then essentially you could then claim that all of Midgard's consensus lives on Cardano L1 directly, which would be a really cool thing to be able to say, right? Because you could just say that Midgard doesn't have its own consensus protocol separate. It's completely dependent on Cardano's consensus and is like locked in essentially, and is only off-chain, like the only thing that happens off-chain in Midgard is just the transaction processing itself, but the consensus stuff all is integrated essentially with Cardano, right? And the fact that eventually I can foresee potentially what we're currently doing with smart contracts for Midgard's consensus maybe being brought down even lower level into Cardano's like actual consensus or ledger level or something, right? For like if the L2 becomes more entrenched into Cardano, I could foresee that happening, and that would probably boost efficiency quite a bit as well, right? So that's kind of the long-term vision. Before then, I think what we're pursuing right now, I think this is in here. So yeah, the solution we're pursuing is going to be via Metro. So we're going to have, when the block contents are posted, in the publicly accessible location, right, which also has to have some replication or whatever, there's going to be a committee of Mithril participants, right, stake weighted and everything, that's going to sign to attest to the fact that this information is publicly available at the location, right? And this will be the proof that will have to be submitted together with the block header, essentially, right, saying that here's the block header and we've confirmed that its contents are available here. Right. This will allow the people who like this will make the primary source of information available, right, for whoever needs to prove fraud. Now, for wallets, which going back to your question, right, wallets and things like that, I imagine there will be secondary sources, indexers, which will consume information from the primary source as it is posted there, right, and index it so that it's more easily queryable, right? Anybody who needs it. So very similar to the way that Cardano L1 ends up being indexed and is available for wallets and all those, folks.
Very cool. So for a normie, can you explain the process of moving some of your funds or tokens onto the Midgard L2 and the process of extracting value out of the L2, like once you're done with whatever dApp you're using on Midgard?
Yeah. So on Midgard, to deposit funds into Midgard, you submit a transaction on L1, that creates a UTXO under Midgard's deposit address, right? And in the data of that UTXO, we describe essentially what's going to be the L2 address and L2 datum of this UTXO once it eventually, transitions over to that, L2 ledger, right?
That essentially puts your keys in your wallet in charge of what ends up on the L2. Is that correct?
Yeah. So you're saying, okay, you're creating a deposit under the Midgard L1 deposit address, and you're giving instructions for what this UTXO should eventually look like on L2, which means what's the address going to be, what's the datum going to be of the UTXO, and the value of the L1 UTXO is just going to be copied over minus fees.
Right.
Yeah. So that's how that works. Now, okay. So with this deposit UTXO, the other thing that we record in the datum, let me just go to that section here, is we also have to keep track of the refund address and refund datum. So in case this deposit for some reason does not get absorbed into Midgard, right? This is where you want the funds to be returned to, right? So standard stuff. The other thing that we include in this datum is called the inclusion time. So this is defined relative to the upper bound of the transaction that created the deposit, right? So you say, okay, this transaction was validated sometime within its validity interval. Assume that you take the latest time, the upper bound, add a certain wait duration to it, and that's a protocol parameter for Midgard, right? And what we're saying is the block that includes that time interval, in Midgard, every block is exclusively accountable for some time interval, right? So every block kind of claims a slice of time of the timeline, right? And so what we're saying is, if a deposit exists on L1, right, and it has a certain inclusion time, the block that claims the time interval within which this inclusion time falls must recognize this deposit.
Interesting. Okay.
And if it doesn't, it has committed fraud.
Okay. So that prevents that's an anti-censorship.
Yeah, deposits can't be ignored. Like if fraud proofs are being submitted promptly and people are vigilant, right, then deposits cannot be ignored, right, because they have specific inclusion times, right? And as well, blocks have to be produced, right, they have to be continuously produced, right? Obviously, if block production stops, then you can't prove fraud about a non-existent block. We do have a fallback method against that, which I'll maybe talk a little bit about later. But yeah, so long story short, deposits must be recognized in the blocks that are responsible for their inclusion time. Withdrawals work the same way. In order to initiate a withdrawal from Midgard, you create a transaction that creates a UTXO under Midgard's L1 withdrawal address, right? It references some UTXO in the L2 ledger and says that this UTXO needs to be withdrawn, right? And withdrawal orders, this is what this UTXO is called, right, on L1, are also assigned inclusion times. And so in the same way, they cannot be censored by blocks that are non-fraudulent, right? And similarly with transactions. So normally, you submit your transactions on L2 and the block producer just includes them in the block and everything's fine. But if for whatever reason the block producer is censoring you, you can actually submit a transaction order on L1, right? This transaction order will get an inclusion time attached to it, and that will prevent it from being censored by whichever block ends up being responsible for the time interval that the inclusion time falls in.
Okay.
Right?
So like if you care highly about speed, you should do your transaction directly on the L2. If you care highly about not being censored, you could pay the extra L1 fee and ensure that your transaction gets processed by submitting to the L1.
Yeah.
Awesome.
Yeah. Yeah, and potentially you might be able to double up, so submit it here and there and see which one goes first. Something
Oh,
like that.
okay.
Yeah.
Cool.
Well, with the specifics of that have to be worked out, right? But in principle, we might be able to make that possible.
Mhm.
So yeah,
Now, all this is open source code.
Yeah.
Are there any plans to do multiple Midgards? Like, I assume it's entirely possible to have multiple instances of Midgard running at the same time.
yeah. Well, the instance of Midgard is parameterized by UTXO that gets consumed upon initialization. So you can
Okay.
instantiate new Midgards very easily. And of course, all the protocol parameters are configurable. Well, right now they're all hardwired, but you don't want to
Yeah.
will be configurable,
Right.
Yeah, so it's all open source, can be forked. And indeed, I think that's a big part of the vision, because the point of L2s is for them to be tailorable to specific use cases,
Mhm.
right? And so we'll probably have, a vanilla Midgard that's going to continue operating, because for most use cases, just using the vanilla Midgard is going to be perfect, right? And
Right. And it benefits you to have multiple dApps running on the same instance of Midgard. Right.
And there's economies of scale, right? You
Right.
don't want to fragment your Midgard instances too much, because then you don't
Right.
get to benefit from lowering the fees for the transactions that come in. So there is a little bit of that going on, but at the same time, if there's a very compelling reason to have an instance that forks and perhaps uses slightly different ledger rules on L2,
Mhm.
right? Or processes transactions on the L2 somehow differently, maybe changes a little bit how what information gets posted on the on L1 via the block headers or something, right? Something that's very use case specific.
Mhm.
Then people have the option to do that if they want. It's all open source under very permissive licenses, right?
Mhm. Talk a little bit about tokens. I think when I read the paper, I saw something about token minting directly on L2 is not supported, or is that something I misunderstood?
Um, token minting, we do have a mechanism in mind for how to support that.
Mhm.
It's not in spec yet because it needs to be written up, and because of that, the spec right now assumes that no minting is done, and the implementation also assumes that it is not done. But Phil actually thought up of a really awesome idea for how to allow this. You would basically be able to upgrade any L1 minting policy, right? And sort of embed it. So if you can think, right now, every Cardano script has redeemers, right? It can define its own redeemers, and it's able to dispatch on the different redeemer types. And the way that's handled under the hood is that the redeemer data structure that's provided has like an integer index, right? So each redeemer is just one of those integer indices, right? And then the payload for the redeemer is contained inside of this constructor. So what Phil thought of is essentially the script context itself is something that Cardano's ledger creates based on the contents of a transaction, and it passes it into Plutus, right, for the evaluation of the script. And the script context itself has an integer like constructor index. And so what we could actually do is the Cardano's integer constructor, I think, is like 0 or something, like the very first one. We could use a different constructor index for the script context for stuff that gets evaluated on Midgard, right? First of all, that gives us a little bit more flexibility in terms of customizing L2 ledger rules for stuff that makes a little bit more sense in Cardano land,
Right.
Midgard land. But second of all, you can detect whether you are operating in Cardano L1 or in Midgard based on that integer, right? And everybody else, whoever cares about if they're operating on Midgard or on Cardano could detect it via this script context integer like index, right? Whoever doesn't care can just look at the script context itself and operate as usual. So you kind of have that isomorphic-ish interoperability by storing that index integer, right? While at the same time, if you do want to distinguish the environments that you're operating in, then you can do it by looking at that integer index, right? And so you could take a Cardano L1 minting policy and you can kind of upgrade it to be aware of the context in which it's running, right? And you could say that if it detects that it's running in a Midgard script context, right, then you allow minting and minting and burning under these rules. If it detects that it's under the Cardano in the Cardano environment, then it delegates minting and burning to Midgard based on Midgard's proofs about the UTXOs that are being withdrawn, right? The tokens that need to be minted in order to fulfill the payout requirement for that withdrawal.
Yeah, I'm just thinking of certain protocols that they mint tokens as part of what they do, like a DEX where it gives you, an LP token or something when you've deposited.
Yeah, well, those tokens fundamentally can't be minted by Midgard, right? Because they're minting, in order for tokens to be mintable on an LP, Midgard or otherwise, right? The minting policy needs to be aware of Midgard and to delegate authority to it to be able to, right? So that's a fundamental requirement, because otherwise, well, how do you know that this is the Midgard that you care about? And also, coming back to the previous discussion, if you have multiple instances of Midgard run by different operators, right, with different levels of vigilance, right, the minting policy essentially needs to whitelist which L2s it allows to mint its tokens, right? And so, but we can save a lot of effort because you don't need to rewrite the whole minting policy. You can just embed it inside of this wrapper, essentially, right? That then allows the token to be minted here or there. But the cool thing is that after you've embedded the token, the minting policy within this wrapper, the minting policy ID remains the same between L1 and L2.
Awesome.
Right? So you don't have
that's very cool.
So yeah, we're in the process of writing that up, and then once that's written up, we'll adapt the rest of the spec to interact with it accordingly. I think the current thinking is if you have deposits that contain any of these Midgard compatible is maybe the wrong word, but Midgard mintable tokens, right? We're just going to burn them when the deposits are absorbed into the Midgard's reserves, and then we're going to mint them on demand when paying out withdrawals according to what they should be, based on what the L2 UTXO says should be contained in that UTXO, right?
Okay.
That's the current thinking.
Cool. I only have, I think, one more question, which is when. The question everybody always asks the devs. Sorry.
As a fellow builder, the question that we all hate, right?
Yes.
Well, so here's what we have right now. Right now, we have an MVP prototype that contains off-chain code that is able to generate L2 transactions, generate blocks, from these L2 transactions with all the Merkle tree structures, everything, right? Submit them on chain, right, into the queue, merge them and stuff, right? All of that is happening, and the demo that we did internally, I don't know if we've publicized it. We'll probably show it to everybody at Builderfest. Probably that's the next time we need to do so. But yeah, I've been able to see really awesome TX production rate. I mean, these are dummy transactions, so a little bit of way to solve, but at the same time, the code is also not optimized, so it kind of goes both ways. But yeah, it's way more transactions that are possible to get through Cardano L1 already with this MVP prototype. So it's really encouraging. The on-chain code base. So let me this is all visible, and even this demo that I talked about, you can run it yourself if you want, so there's no secrets here. So anyway, in terms of consensus protocol, so we've implemented the operator directory, but we've implemented the scheduler, the state queue. Settlement queue is in review, about to be merged. Midgard Harbor Oracle is the next one up. Reserve, we need to finish up the design of this and implementation. And then the escape hatch is something that we'll do a little bit later. This is that fallback mechanism that I alluded to in case there are no blocks being produced in Midgard. Essentially, long story short, the escape hatch contract allows you to post a non-optimistic block to the state queue, which means it's not backed by a bond, but its contents are impossible to be, like it's impossible for them to be fraudulent. So anything that makes the escape hatch block has already been proven, essentially, right? And this allows you to have blocks be produced if the operators stop being active, right? And correspondingly, deposits be recognized and withdrawals to be recognized, that kind of thing. So this is something that we'll add in, but not necessarily immediately, right? Because first we want to see like the more normal operation of this, where everything kind of works together to get a sense of the system, properties and stuff, right? So, long story short, the on-chain code for the consensus protocol is getting there, right? At least the first full iteration of it. We have the off-chain code base, which right now does not interact directly with the on-chain contracts yet. So far, we've just been using the same data structures, right? The same UTXO structure on-chain, but it's been like without validation checks, right? So now comes the difficult part where we need to merge the two together, right? Which, as you may know, Andrew, from your experiences with dApps, right, is a tricky time. But we're about to start that, right?
Very cool.
Yeah, and then once that's done, I mean, we have the L2 ledger stuff to. We've implemented several of the fraud proofs already. We need to implement the custom L2 ledger rules. So we're exploring several ways to actually implement that, either via the Haskell Cardano ledger library, or Scalus might be coming out with their own ledger rules that are customizable. There's the Go stuff from Blink Labs, right? So we're kind of exploring what's the best way, most flexible way to implement our L2 ledger rules, and then based on those, detect fraud and then construct the fraud proof. So that's another stream kind of going on at the same time, right? And then Phil is kind of exploring this stuff here with the off-chain data structure together with several of the IOG folks, which are kind of helping us out, with that stuff. So yeah, there's several streams right now, and some of them are starting to connect. I think we'll see more the pace will pick up in terms of the integrations over the rest of the spring and the summer. So you'll kind of see it happen in the repository, which is now public. That's kind of where things at. But I'm fairly optimistic that we'll be able to do at least a limited testnet, deployment. I mean, we are already deploying technically the MVP prototype on testnet. It's just not interacting with any of our on-chain contracts, right? We'll continue to do that, and so I guess you'll just see progressively more advanced, more complete iterations of Midgard be deployed on testnet. And eventually, we'll open it up to other people to interact with. But again, as I said, anybody can clone our repository, deploy it on public testnet, and open it up for anybody to interact with. So it's not a big sort of
the fun of building in public.
Yeah, exactly. So yeah, that's kind of that.
Okay. Is there anything that I didn't cover that you definitely want people to know about Midgard? I know we covered a lot today.
Well, there's a whole thing going on about executing the actual Pluto scripts on L2 and then generating fraud proofs based on that, which is actually one of the so I mentioned the throughput of Midgard as being its key benefit, right? The thing that we're Cardano. But the other key benefit, and one of its differentiators from other L2s on other blockchains, like Ethereum, for example, is that we really get to leverage the locality of transactions effects within a UTXO-based ledger to create very small pinpoint proofs of where things go wrong. So whereas in other ecosystems, on Ethereum, you basically have to simulate the whole blockchain to sometimes to detect what went wrong, because your particular thing that went wrong might be referencing anything out there in the entire blockchain state, right? In Midgard, it's more explicit and local, right? So we know what the transaction's inputs are, what its outputs are, and we know what script it ran, and that script is deterministic relative to the contents of the transaction, right? And so in the script, we can actually pinpoint where the script's like interpreter, at which step it went wrong, what it should have done, and what it did instead, right? And so that's all you need to submit on L1, right? You need to show, okay, this transaction was part of this block. This transaction included this input, which required this script to be executed, right? This script, when executed with the the corresponding stuff from the transaction, i.e., building up the script context, right? When started operating until it tried to reach the conclusion, and at step 1071, it did the wrong thing. So I just need to prove membership of the transaction in the block, the input in the transaction, the script in the transaction for the purposes of validating the expenditure of this input, right? And then the membership of this particular fraudulent step in the trace of executing that script, right? So it's very like pinpointing, and that means that constructing fraud proofs should be cheap, easy, and simple, right? Well, we'll write the software to do it for you, but the point is it doesn't require a lot of resources. And submitting them on chain and verifying that the fraud proof is correct should also be relatively simple, because again, it's pinpointed, right? And and the step that's being verified is very small. It's simple. It's not very complicated, right? Whereas on Ethereum or something, right? And I'm picking on Ethereum because it's where a lot of the L2s live, right? But over there, to construct a fraud proof, you have to have enough resources to simulate the entire blockchain state, and then compare it to what was declared on L2, and the L2 itself might be structured somewhat differently. And then there's so much going on that the amount of information that you have no choice but to put into your fraud proof becomes enormous. And then validating that on chain, you're paying gas fees for the whole thing. So this is something that we're avoiding potentially at Midgard, right? I mean, you'll see it once we actually show you the actual fraud proofs being generated, evaluated, you'll actually see some benchmarks to be able to compare this. But in principle, it should be like orders and orders of magnitude, like just easier and cheaper, better.
Incredible.
Yeah.
Very good. Well, I'm going to go ahead and stop the recording here, but I want to thank you for your time and your knowledge and everything you're doing on this project. And thank you to the Midgard team.
Yeah, thanks, Andrew.
Thank you guys for watching that awesome conversation with George. And there's only one thing left to do: nerd out.